Hello everyone, now I am going to explain about a topic on a direct memory access. This is one of the method of the modes of data transfer in an input-output interface. So first of all, what do you mean by input-output interface? Here, the input-output devices are connected to an CPU through an interface, are known as input-output interface. So what is the main purpose? We need to transfer the data from input devices to the CPU to the output devices. So what it is called as? It is called as modes of transfer. Then how many types of modes of transfers are there? Three types. What are they? Programmed IO, interrupt initiated IO, direct memory access. So direct memory access is a third method. Then what is the drawback of the what are the drawbacks of the first two methods? In the programmed IO or interrupt initiated IO, the CPU waiting time is increases. So as the waiting time is increases, the performance of the CPU is decreases. The speed of the transfer also decreases. In order to increase the speed of transfer, data transfer, we are keeping a CPU in an ideal position and the input output device directly contact with the memory. That's why it is known as direct memory access. Without the intervention of the CPU, the input output device it will communicate directly with the memory. That's why it is known as direct memory access. Let us see the basic diagram of this DMA. So what it consists of? So it consists of an bus request signal, bus grant signal, and here it consists of an address bus, data bus, read line and write line. So here this is a DMA, and here whenever the input is given from an input output devices, so therefore here it is going to request a bus to an CPU, because here what we are doing, without the intervention of the CPU we are directly accessing the memory, accessing the data now. So therefore here what we are doing, first of all here the DMA has to request a bus. So as the CPU is going to keep that data line, address line, control lines in an ideal position, then DMA will take care of that data transfer. So therefore here first of all it will request a bus to an CPU. So therefore here the bus, whenever it is requesting to an CPU, the CPU will immediately sends one signal as a the whatever you are requesting bus na, so that bus is granted. So whenever the bus is granted, so what is the value of BG here? So therefore here the BG value is equal to 1. If the BG value bus is granted from the CPU, so what are the lines are there here? The CPU has a address bus, data bus, control bus. Okay, so therefore here address line, data line, control lines are there like read line and write line. So here whenever the BG is equal to 1, the CPU is going to keep these lines as a disable. So therefore nothing but it is in an high impedance state. So therefore here whenever BG is equal to 1, okay, so therefore the DMA will came into existence and it will transfer the data to an input output devices without the intervention of the CPU. So that is the main concept of the direct memory access. So this is the basic block diagram of a DMA controller. So this DMA controller it consists of one control logic, data bus buffers, okay, and address registers, word count registers, and control registers. So in the control logic, it has a DMA select lines, register select lines, read line, write line. Here the read line and write lines are the bidirectional lines. And here it has a bus request line to an CPU and bus grant line from an CPU and an interrupt signal from an input output devices. And here it consists of one internal bus that is connected to an address register, word count register, control registers, to an data bus buffers to a data bus, and also address bus buffers are connected to an address bus. Whenever input output devices they are going to transfer any information, first of all it will request to a DMA. So whenever the input output devices it will send say one request signal to a DMA, so it will activate the bus request line to an CPU. So therefore here the CPU is going to grant a bus. So whenever it is going to grant a bus, here the BG value is equal to 1. So therefore here it will select the DMA selection lines and it is going to activate the read line and write line. So therefore here, whenever it is going to read line and write line, the address bus is going to store the address in an address bus registers, address bus buffers. And here, as the number of word count is as the address register value is increases, the word count register value is going to be decreases until and unless the word count register is equal to 0, the DMA is going to stop its data transfer. Now we will see the DMA transfer in a computer system. So this is the DMA controller that we seen earlier. Like it consists of a DMA select, register select, bus request, bus grant, and interrupt. Okay, DMA request signal, DMA acknowledge signal to an input output devices. Okay, so directly is connected to a memory, random access memory, which is going to store the information or which is going to give the information, and here the CPU. So see here, whenever the input output device they want to transfer an information, first of all, it will request a to an DMA, like that is known as a DMA request. So whenever the DMA controller got a request from a input output devices, so it will going to activate the bus request line. So therefore here it is going to request a bus, it is going to request a bus to an CPU. So therefore here the CPU has to be in ideal. The normally we know that the CPU has a read line, write line, address line, data line. So whenever it is requested by a bus from a DMU, then it is going to be it is going to keep these lines in a high impedance state. It will disable these lines. So then it is going to grant a bus to an DMA. So whenever the bus is granted, so therefore here the BG is equal to 1. So whenever it is BG is equal to 1, here the DMA has the read line, write line, and here these read line, write line are going to become a output lines to an random memory access memory, like they are going to behave like a output lines, and it will specify the either read operation or write operation for the data. And here peripheral device like input output devices receives a DMA acknowledgement and it will put a word in a data bus. Okay, so thus the DMA controller read operation or write operation supplies the address for a memory. So likewise, whenever the word is transferred, the DMA increments its address registers and decrements the word count registers. If the word count register is not zero, the DMA is keep on checking the request and coming from the peripheral device. If the word count is equal to zero, then the DMA is going to stop the operation. If suppose bg value is equal to 0 means what here, the bg value is equal to 0 means what, the bus is not granted by the CPU. So therefore here if it is not granted, so it will activate these address line, data line, control lines here at this time, these read write signals. Okay, so these signals are going to be input lines, and here to an random access memory, they are going to transfer the information to an random access memory, and it is going to give the information to an input output devices. So this is about the operation of a DMA transfer. Thank you.